Welcome to Math Masters everyone. So today we'll be exploring the concept of functions and function machines. The learning objective for this session is to be able to understand functions and to be able to write an expression for the function machines. Now what exactly is a function machine? This is what a general function machine looks like. So you have the input. The input is something which you put in, followed by which you have the functions. The functions of which are those numbers, are those operations which act on the number and therefore give an output. The output is over here. So it's like input to functions to output. Let's take an example. We have the variable n as the input, which is what we are putting into the function machine, and our function is plus 6. So the operation over here is addition. We are adding 6 to the variable n. The output is a result of the entire process. So in this case, we have n plus 6 as our output. Let's take an example with the number 5. So as you can see, 5 is the input, and our function is plus 6 into 2. It is important to note that we have to maintain the order in which the operations are given. Although the BODMAS rule states that we have to apply multiplication first, then addition. In this case, we'll strictly follow the order. So we have plus 6 and then into 2. So we do 5 plus 6 and then the entire thing in brackets, which will be multiplied by 2. So if you solve it, it will be 5 plus 6, which is 11, and then into 2, 22. That is the output over here. Let's take another example. Now we have the input as a number 35, and the functions we have is divided by 5 and then multiplied by 2. So we'll do 35 divided by 5, that will be 7, and multiplied by 2, that will be 14, and that is our output over here. Another example involving decimals or even fractions would be 1.5. 1.5 is our input in this case. The functions are plus 2.5 and into 2. So 1.5 plus 2.5 is equal to 4. Into 2 would be 8. So that is our output right over here. So if we follow BODMAS in any of these function machines, so let's take an example again with 1.5. If we follow BODMAS, we will multiply first and then add. So 1.5 into 2, that is 3, plus 2.5, that would be 5.5. Whereas our answer, without following BODMAS, is 8. Let's apply the function machine to the word problem. Our question is, again, a rectangle has height b, the width is 5 more than the height. So our input, or in this case the height, is b, and our operation to find the width is plus 5. So it's going to be b plus 5, that is b plus 5, which is our width as a whole. Now to find the perimeter of such a rectangle, we have b and b as the height, b plus 5 and b plus 5 as the width. So perimeter is equal to sum of all these sides. So we will do b plus 5 plus b plus b plus 5. So when you add all of them up, you will get the answer as 4b plus 10. So that is a perimeter. So now we have also applied function machines to word problems, and we could also do so in real life application. So that we have reached a success criteria, which is to be able to solve a given input as well as apply them in word problems and further on in real life applications.